Okay, welcome back. This is Miss Henson. I hope you all had a fantastic Thanksgiving break. We're going to start this chapter by finishing up systems. We learned systems of equations last week and the week before Thanksgiving. And we learned how to do graphing, equal values, and substitution. Today we're going to show you the last method, which is elimination. Let's review real quick how to do the systems with the other three methods, just so we can make sure we remember. When you're graphing, you want to just be able to plug it in the calculator. So you want to solve for y. Solving for y, you're going to have two steps. You're going to either add or subtract x, then you're going to divide. So for this first one, it's a negative 1.6x, so I'm going to do the opposite, and I'm going to add 1.6x. So a positive 1.6x, and then that negative 24. Step 2, I'm going to divide out this number so I can get y by itself. So y equals 1.6 divided by negative 3 over 2. It's going to be negative 0.5. Bring down your x. Negative 24 divided by negative 3.2 is positive 7.5. So that's our first equation. To get our second equation, again, solve for y. So it's a positive 2.6. So we're going to subtract 2.6 to the other side. So minus 2.6x, and bring down your 2. Step 2 is always going to be divide. So then y equals negative 2.6 divided by 2.6 is negative 1, so negative x. And then 2 divided by 2.6, double check that real quick. That one's going to be a super long decimal. When you get super long decimals, you don't want to leave that as a decimal. If you round it off, it's going to change your answer. So I'm just going to keep it as a fraction. How you do that in the calculator? So clear that out. 2 divided by 2.6. Like I said, it's going to give you this really long decimal. So keep it exact, keep it as a fraction, just hit math, enter, and enter one more time. And we'll use 10 over 13. You don't want to use super long decimals because they're going to mess up your answer. And then we can just plug it in. So we had negative 0.5x plus 7.5. And then we had negative x plus 10 over 3. Or 13. 10 over 13. Okay, then you're going to want to graph it. And you want to see if you can see where they cross. On this one, I can't. So in order to find it, we're going to do zoom and zoom out, number 3. And you're going to hit enter. 1 second.
Second lunch dine-in. May head to the cafeteria. Second lunch dine-in.
So now that I can see where they cross, we can do our second trace 5. So second trace 5. Now you're going to want to watch the directions on if you have the calculator app on your phone because they look a little different. They say left bound, then right bound, then enter. So all you have to do on that is go to the left side of the points, then hit enter. So I'll show you on this one. You're going to go to the left side of the points, hit enter. Then yours isn't going to say second curve. On the calculator app, it says right bound. So you're going to go to the right side of the graph, the right side of your point right here, and hit enter. and then yours will give you the answer. We got super long decimals, so we can just round these off because it's our final answer. So we got negative 13.46. And then 14.23. Make sure I rounded that correctly. Yep. And then make sure you put it in parentheses because anytime you have a point or anytime you're solving a system of equations, you're going to want to put it in parentheses because that's how we write points. That's how we write an XY point. Perfect. Okay, method 2, let's review equal values. So publishing site Look at Time had 5 million visitors in 2009. Each year after that, the number of visitors rose by 13 million. Online auction site Buy Your Stuff had 60 million visitors in 2009, but each year after that, the number of visitors fell by 2 million. When will they have the same number of visitors, and how many visitors will that be? So we need to find our variables. You can do multiple things to find your variables. I'm going to let's go to the question. It says, when will they have the same number of visitors? When is going to mean we're looking at time. What's our time in this problem? Days, weeks, months, years, minutes, seconds, hours. What's our time in this problem? You can compare each year. The number changes. So this is going to be the number of years. And then it said, and time is always going to be your x. It's independent. That's why I put it here. Then it says how many visitors. So that's our second one. The visitors depend on the time. So this is going to be your total visitors. Now there's one special thing about this that you're going to have to watch out for. This isn't just random visitors. This is 5 million, 60 million, 2 million, 13 million. So your visitors here, instead of writing out 2 million visitors and solving our equations with that, we have a little shortcut. We can just put total visitors in millions. That way we can just use 2 instead of using 2 million in our equation. All we get to do is use 2. That'll save you from writing a ton of zeros. So let's go to our equation. So we have 2 different types of equations. We have y equals mx plus b. That's your slope-intercept form. Then you have standard form, ax plus by equals c. Which one would we use here? One of the best ways you can figure this out is looking at B or C. B is your initial. Did we get the starting amount of visitors for these websites? Or C is your total. Did we get the total at the end, like that's the max amount of people they had visit their website? So let's look at all of our numbers here. Publishing site Look at Time had 5 million visitors in 2009. Is that their initial or is that their total of all time? That's going to be an initial. Because then each year after that, the number of visitors is going to grow. Your total is your stopping point. The initial is the only one that can grow or fall, increase or decrease. Total has to stop. So because it's growing after that 5 million, that's going to be your initial. So we're going to go with these equations. Y equals mx plus b. Because we have initial values. Another way you can tell are your variables. If your variables are independent and dependent, you're going to go with y equals mx plus b. Standard form does not have independent and dependent. And these are independent and dependent. Your visitors depends on time passing, on each month, on it growing or falling every single month. So that's another way you can tell it's going to be y equals mx plus b. So for look at time, what's their equation? So we got y equals, what's their slope? How much is it rising or falling every year? Well, it says each year after that number of visitors, after that, the number of visitors rose by 13 million. So that's how much it's going up every year. So that is our slope. Then what did they start off with? They had 5 million in 2009. So that's their initial. Okay, the second site, buyer stuff, what is their slope? It says each year after that, the number of visitors fell by 2 million. So 2 is your slope, but it fell. What does that mean? That means it's going to be negative. So -2 for your slope. It's going down 2 every year. How much did they start with? They had 60 million in 2009. So we're going to add 60. So it's falling 2 million every year, but they started with 60. Okay, and we're doing equal values on this. So all you have to do is set these equations equal to each other. Then you just got 3 steps. Get your x's together, then get your regular numbers together, then you're going to divide. So to get my x's together, I'm going to move, let's move 2. So it's -2, so we're going to do the opposite, and we're going to add 2x. So 13x plus 2x is 15x. Then I'm going to get my regular numbers together. I have a +5, so I'm going to subtract it. I'll go over here. So 15x equals 55. Then this is 15 times x, so to get rid of it, we divide. And then 55 divided by 15 is just going to simplify to 11/3. Okay, then to get your y value, you're just going to take that 11/3 and plug it into either equation. Let's just go with the first one. So plug it into x. Now, the reason I use the fraction on this instead of the decimal is because 11/3 is going to give you, like if we simplify that out to a decimal, it gives you this really long decimal. If we round it off, it's going to skew our answer just a little bit for y. So I'm going to leave it as a fraction, and then we can change it when we go to our numbers, or go to our questions. And then we just plug this in. 13 times 11/3 plus 5 is 158/3. Now, when we do our questions, when will they have the same amount of visitors? So when is your time, so that's going to be x. And 11/3 years doesn't make sense, so that's where I would go to the decimal. So rounded off, 3.67 years. So when you write your answer, use the decimal, because who knows what 11/3 years is? That doesn't make sense. But I know what 3.67 years is. Same thing with 158/3. How many visitors? That's not 158/3 visitors. That we want to change to a decimal as well. So 158 divided by 3. Super long decimal again, but just round it off. So 52.67. And then remember that special thing we talked about. These are not just 5 visitors or 60 visitors. This is 5 million. That's why we wrote million in our variable. So this is 52.67 million visitors. Perfect. Okay, let's try method 3. Method 3 is substitution. So all that means is either get x or y solved for and plug it into the other equation. So for our top equation, this one has y by itself. So that's solved for. So I'm going to take the other piece and I'm going to plug it in for y on the other equation. So bring the first part down, 2 times x minus 3. But instead of minus y, I'm going to put the box, minus x minus 3. And then equals 7. So you're just taking this equation and writing it again. But instead of y, put the box right there. Okay, and then let's solve. So let's distribute them out to both parentheses. 2 times x is 2x. 2 times negative 3, negative 6. A negative, so a negative 1 times x is negative x. Negative 1 times negative 3 is positive 3 and equals 7. Combine them up. 2x minus x is x. Negative 6 plus 3 is negative 3. And then the opposite of minus 3 is plus 3. So if I add 3 over, 7 plus 3 is 10. And then just plug it back into the equation. So we had that y equals x minus 3 up here. So plug it back in, and 10 minus 3 is 7. So your whole point, the whole xy point in parentheses, is 10, 7. So that's your review of all the past methods. One more thing we want to review. How do you tell if they have one solution, infinitely many, or no solution? So for one solution, let me erase this so we have space. For one solution, they're going to have different slopes. That's one solution. For infinitely many solutions, you're going to have the same slope and the same y-intercept. And then for no solution, you're going to have the same slope but different y-intercepts. So all you have to do is solve them for y and see what the slopes and y-intercepts are. So the first one, these are already solved for y, for a. So our slope, that's 1 on both of them, so those are the same. But our y-intercepts, negative 4 and negative 3, those are different. So which one is the same slope but different y-intercepts? Perfect. No solution. Okay, second one. Well, y is already solved on the first. So on the second equation, we need to solve it. We need to solve for y. So we have 2 times y and we have plus 2. Do the opposite of your order of operations. Do plus and minus first. So subtract it over. I'm going to move my y out front. So 10x minus 2. And then that's 2 times y. So divide it out. 10 divided by 2 is 5. Negative 2 divided by 2 is negative 1. So we have the slope is 5 on both of them. So it's the same slope. The y-intercept is negative 1 on both of them. So it's the same y-intercept. So what answer is that? Right, infinitely many solutions. Okay, and the last one. Solve it for y. So adding and subtracting first. Yep, a positive 3, so we're going to subtract it. So minus 3x and a positive 1. That's 2 times y, so to get rid of it, we divide. So negative 3 divided by negative 2. That doesn't simplify, so we can just leave it. 1 divided by 2, that doesn't simplify either. Second equation, you have 4 times y, so the opposite is divide. So 6 divided by 4, that's going to simplify to 3 over 2. 2 divided by 4, that simplifies to 1 over 2. So our slopes, we have negative 3 over 2 and positive 3 over 2. So those are different. And the only one up there that has different slopes is one solution. It doesn't even matter what the y-intercepts are. If your slopes are different, it's always one solution. Okay, so let's look at the new method. The new method is elimination, which just means, just like equalizing substitution, we're going to eliminate a variable so that we only have to solve a one variable equation. For these, you want to look for equations that are in standard form, which is ax plus by equals c. That's going to be the best time to use elimination. And they need to have opposite coefficients so they can cancel out. So if you have 3x and negative 3x, well, 3 minus 3 is 0, so that eliminates the other one. But if you have 3x and positive 3x, that doesn't eliminate. That gives you 6x. Same thing if you have negative 3x and negative 3x. That doesn't eliminate either. That's just negative 6x. They have to be opposite in order to cancel out. So you want to look for variables that have opposite coefficients. So let's look at our first example. So they are in standard form. That's what we want. The x's, are they opposites? No. This one's 3 and this one's 1. They're different numbers, but they're not opposite, like 3 and negative 3. We want them to be the same number, but different signs. What about our y's? Are they opposite? Yes, they're both 2, but one's positive and one's negative. So those are opposite. So then we're just going to add the equations together. 3x plus 1x is 4x. 2 minus 2 cancels out. And then 4 plus 4 is 8. Now you only have one variable to solve for, so it makes it a lot easier to solve when your variables cancel out like that. So how do we solve for x? Well, this is 4 times x, so the opposite is divide. And then 8 divided by 4 is 2. And just like every other method we've done, once you get the x value, you plug it back in to get the y value. You can plug it back into the second equation or the first equation. It does not matter. We chose the second equation just because x was by itself. It's a little simpler when x is by itself. So plug it into x, which is what we did here. Bring everything else down. And then we just solve. Do opposite order of operations. So this is a positive 2. So to get rid of it, we subtract 2. 4 minus 2 is 2. Bring down your y. That's negative 2 times y. So the opposite is divide negative 2. So y equals 2 divided by negative 2 is negative 1. So now you have x, you have y. All you have to do is bring them over to your point, and you're done. Now you can always check it. These are super easy to check. All you're going to do is you're going to take your point and plug it back into both equations and see if it's true, which is what we did over here. So x is 2, y is negative 1. So we plug 2 into x, y into negative 1 into y. And when we solve this side out, we're going to get 4 equals 4, which is true. So that one's good. Then we plug it into the second equation. Plug in x, plug in y, solve this side out, and we get 4 equals 4, which again is true. So we know our answer is correct. So what happens if there's no opposite coefficients? Like we have 3 and 3, but they're both positive. So if we were to add those up, they're not going to cancel. They're going to give us 6. We have 1y and 2y, but they're not going to cancel. If we add those, we're going to get 3. So what happens if they don't cancel? For that, all you're going to do is multiply. Get something to be the opposite. So if we have 3x and 3x, we need one of them to be negative. Pick one. It does not matter which one you pick. Let's go with the top. I need 3 to be negative, so I'm going to multiply by a negative 1. Because negative 1 times 3 gives me negative 3. And bring down your x. But if I multiply that by negative 1, I have to multiply that by everything. I can't just change one letter. I have to change all of it. So distribute your negative 1 out. So negative 1 times 3x is negative 3x. Negative 1 times y is negative y. Negative 1 times 1 is negative 1. And then my second equation, I'm just going to bring it straight down. Don't mess with it. So if the numbers are the same but one of them's not negative, just multiply by a negative 1. And again, just pick one of your equations. It does not matter which one you pick.
Third lunch, grab and go. Can head to the cafeteria. Third lunch, grab and go.
Now we do have opposite coefficients. We have negative 3 and positive 3. And those are going to cancel out. And we'll just add everything. Negative 3 plus 3 is 0. Negative y plus 2y is a positive 1y. And negative 1 plus 4 is 3. And then there's nothing in front of y, so that's our y. To get x, just pick an equation. Plug it into either one. I'm going to go with, let's go with this, y is by itself, so that one's going to be super easy. So plug it into y. I'm going to go with the first one. and solve. We have plus 3, so I'm going to minus 3. 1 minus 3 is negative 2. Then I got 3 times x. The opposite is divide. Negative 2 over 3 does not simplify, so I just have negative 2 over 3. So what's my solution? Your solution's always going to be a point, so get those parentheses. X goes first, so negative 2 over 3, and then y, which is 3. Okay, next. What if the equations are not in standard form? If it's not ax plus by equals c. If that happens, you have to do whatever you can to get them into standard form. The first equation, that's ax plus by equals c. That one's good. The second equation, it's got parentheses. That's not in our equation. So what do? Just distribute. So our first equation was good. I'm going to bring it down. The second equation, 5 times x, is 5x. 5 times y is 5y, and all of that equals 5. Now it's in standard form. Then you have to ask yourself, do we have opposites? Are the x's opposite? No. 3 plus 5 is going to give us 8. That's not going to cancel out. What about our y's? Would they cancel out? Negative 5 plus 5 is 0. So if we add them up, that's going to cancel out. Add up everything else. 3x plus 5x is 8x. 11 plus 5 is 16. How do you get rid of 8? That's 8 times x, so we're going to divide. 16 divided by 8 is 2. And then pick an equation, it doesn't matter which one, and plug 2 back in. This time I think I'll go with the first equation. So we have 3 times 2, which is x, minus 5y equals 11. And solve it. 3 times 2 is 6. That's a positive 6, so to get rid of it, I'm going to subtract. Bring down my negative 5y. 11 minus 6 is 5. That's negative 5 times y, so how do I get rid of it? Divide. 5 divided by negative 5 is negative 1. So what's the whole answer? You got your point, so you got to get those parentheses. X is 2, and y is negative 1. Okay, sometimes you're going to have coefficients that are not the same. If that happens, all you need to do is multiply so that one of them is the same. You want them to be opposites, but the number needs to be the same. One needs to be positive, one needs to be negative. But so 5 is positive, we need the other one to be negative 5. So they still have to be opposites. So can we multiply so that the x's would become opposites? Could we multiply something by 2? Or could we multiply something by 4 to make them opposites? Yes. We could multiply the 2 by negative 2. So we would have -4, and then they would be opposites. Before we do that, could we make the 5 and 3 opposites? I always like to go to the smaller number because that's the one you're going to have to multiply up to the bigger number. Does 3 multiply by anything to give you 5? No, so we can't use y. We have to use x. And we said that we could multiply this by -2. But again, you can't just multiply the x. You have to multiply that by the whole equation. What you do to one side of the equation, you still have to do to the other side. So -2 times 2x is -4x. -2 times 3 is -6y. -2 times -14 is 28. Our second equation, just bring it down. And let's add them up. So -4 plus 4, that cancels. -6y plus 5y is -1y. And 28 plus a -1, or 28 minus 1, is 27. Then how do I get rid of -1? Well, the opposite of -1 times y is divide. So y equals 27 divided by 1 is -27. Then we just plug it back in. You can pick either equation. It doesn't matter. I'm going to go with the first one. So this is y, so I'm going to plug it into y. And then solve it out. So 3 times -27 is -81. Double check. Yes. And the opposite of -81 is +81. That'll give me 67. And then to get rid of that 2, we divide. 67 divided by 2, that doesn't simplify, so we'll just leave it 67 over 2. So what's your answer? You got your solution is a point, so make sure you get those parentheses. X, then y. So x is 67 over 2, and then comma y, -27. Okay? So E, could we make our x's opposites? Go to the smaller one. This is 1. Could we multiply 1 so that it would be the opposite of -4? Yes, we could multiply it by 4. That would give us a -4 and a +4. But before we do that, let's check our y's in case you want to use y. Could we make our y's opposite? Go to the smaller one. Can you multiply -3 by something to get the opposite of 9? Yes, you could multiply that one by a +3. So then you would have 9y and -9y. So this one you have your choice. You can pick whichever one you want. Both of them work. I'm going to go with the y's. So to get -3 to be the opposite of 9, I'm going to multiply by 3. And again, you have to multiply by the whole equation, not just the y. So I'm going to bring the first equation down and then distribute to the second. 3 times x is 3x. 3 times -3y is negative 9y. Negative 9y. 3 times negative 6 is negative 18. Then we'll just add them up. So negative 4x plus 3x is negative 1x. 9y minus y cancels out. 9 minus 18 is negative 9. To get rid of our negative 1, we divide. So negative 9 divided by negative 1 is 9. Then pick an equation. I'm going to go with the second one because x doesn't have a number, so that'll make it a little easier. So x minus 3y equals negative 6. So you get a positive 9. So to get rid of that, we're going to subtract. Negative 6 minus 9 is negative 15. To get rid of negative 3y, we're just going to divide. So negative 15 divided by negative 3 is 5. So what's your whole point? Parentheses, x is 9, y is 5, close your parentheses. So if your numbers are not the same, you need to just multiply one of your equations. Now, another method you could do is you could just use the numbers that you have and cross multiply basically. So that 2 will multiply it up to the top and the 3 will multiply it down to the bottom. However, one of them needs to be positive and one of them needs to be negative, and you get to pick. You pick whichever one you want to be negative. We chose the 2, so all you have to do is distribute it out. Then negative 2 times negative 3x is negative 6x. Negative 2 times 2y is negative 4y. Negative 2 times 9 is negative 18. So that's your first equation. Your second equation, we're going to get 6x, then minus 18y, and a positive 18. Then you just add them up. So 6x, sorry, that's positive. That should be positive right there. 6x plus 6x cancels out. Negative 4y plus 18. Let me see if I can get rid of this real quick. Okay, because that was supposed to be positive 18. That's a mistake. Sorry about that. Negative 4y plus 18 is 14y. And negative 18 plus 18 is 0. To get rid of your 14y, we just divide. So 0 divided by everything is just 0. And then take that 0 and plug it back in. Pick an equation.
Third lunch, dine-in. May head to the cafeteria. Third lunch, dine-in.
Pick an equation. We chose the first one and just plug it into y. So we got 0 in, multiply it out. 2 times 0 is 0. We don't need that. And then divide out your 3. So you have 3. So then your whole point is 3, 0. So if your numbers don't match up and like we're looking at these and 2 can't multiply up to 3, you can just cross multiply them. It's another method that works if you want to do that. Okay, so let's look at a couple word problems with these. So example 2. Cheryl and Jackie work at an ice cream shop. Cheryl earns $8.50 per hour and Jackie earns $7.50 per hour. During a typical week, Cheryl and Jackie earn $299.50 together. 1 week, Jackie doubles her hours and the girls work earn $412. How many hours does Cheryl work during a typical week? And how many hours does Jackie work during a typical week? So to define our variables using let statements, we just need X and Y. And you can go to your questions for these. The first question says, how many hours does Cheryl work? So we have Cheryl's hours. The second one says, how many hours does Jackie work? So we have Jackie's hours. Do they depend on each other? Just because Cheryl works a certain amount of hours, does Jackie have to work that amount of hours? No, these do not depend on each other. Just because you go to work does not mean somebody else has to. So when they don't depend on each other, we're just going to go in order. Cheryl came first, so we're going to make her X. So X is Cheryl's hours. Jackie came second, so we're going to make her Y. So Y is going to be Jackie's hours. And then write your systems. For elimination, you want AX plus BY equals C, which means you're going to have totals. Also, another way you can tell this is because we don't have independent and dependent. Your standard form will never have independent and dependent. It's just going to be two random things, like Cheryl's hours and Jackie's hours. So let's look at the first one. What's our first total? Well, Cheryl earns $8.50 per hour. Per tells us that's going to be a slope, a rate of change. Jackie earns $7.50 per hour. Again, per tells us that's going to be a rate of change, a slope. Cheryl and Jackie earn $299.50 together. That's their total amount of money. So that's one of our totals. Looking at that total, this just says during a typical week, Cheryl and Jackie earn that much money. So $299.50, that's money. So we need to put money here. How much money does Cheryl get? Cheryl earns $8.50. How much money does Jackie get? Jackie earns $7.50. So $8.50 for Cheryl plus $7.50 for Jackie equals their total amount together. But then 1 week, Jackie doubled her work and the girls earned $412. So their new total is $412. $412 is still money, so we're still going to put money here. How much did Cheryl earn that week? Well, she worked her normal hours. Jackie doubled hers, but Cheryl still worked a normal. So she still got $8.50. But what about Jackie? If Jackie doubled hers, what does that mean? Double means you're going to multiply by 2. So times 2. So Jackie normally earns $7.50, but if she doubled her hours, now she's going to get 15 because she's working twice as many hours. So now we have 15Y. Okay. So, we need to solve using elimination. So, do we have any numbers that are the opposite right now? We have $8.50 and $8.50. Are they the opposite? No, they're both positive. Could we get them to be opposites? Yes. All we need is one of them to be negative. So in that case, you're going to go back to example You're going to go back to example B, and if they don't have different signs, you're just going to multiply one of them by a negative. So pick which one you want. I'll do the top one. Multiply by -1 by everything. -1 times 850 is -850x. -1 times 750y is -750y. -1 times 299.50 is -299.50. And our second equation, just bring it down. Okay, then we're just going to combine. Let's add them up. -850 plus 850, that's 0. That cancels out. Sorry, let me get a drink. -750 plus 15y is 750y. And -299.50 plus 412 is 112.50. Then to get rid of your 750, you're going to divide. So 112.50 divided by 750 is 15. Then you just plug in. Pick either equation. It doesn't matter. I'll go with the second one. So it's y, so I'm going to plug into y. So 850x plus 15 times y is 15 as well, equals 412. So just plug in y and solve it out. 15 times 15, that's 225. Subtract your 225 over. 412 minus 225 is 187. Divide 850. 187 divided by 850 is 22. So y is 15 and x is 22. This is a word problem, so all of our answers have to be in words. So let's go back to our questions. How many hours does Cheryl work? Well, we labeled Cheryl X, so how many hours does she work? 22. 22 hours. Use correct units. How many hours does Jackie work? We labeled her Y, so she had 15 hours. Perfect. Okay. And the last one, example 3. A shopper purchased 8 t-shirts and 5 pair of pants for $220. The next day he purchased 5 t-shirts and 1 pair of pants for $112. How much does each t-shirt cost and how much for each pair of pants? So we need our variables, x and y. And let's go to our questions. The first question says, how much does each t-shirt cost? So we need to know the cost of the t-shirt. The second one says, how much for each pair of pants? So we need to know the cost for the pair of pants. So which one is the independent and which one is the dependent? Do shirts depend on pants? Do pants depend on shirts? Think about if you go shopping. If you go shopping, just because you buy a t-shirt, do you have to buy a pair of pants? No, that doesn't make sense. So we have no independent or dependent. When that happens, the first one, this is first, so that's going to be x. So it's going to be the cost of the t-shirts. The second one, we'll label that y. So the cost of pants. When there's no independent and dependent, and when you're using elimination, you want to go with AX plus BY equals C. So what are the totals? Well, our first total is $220. Now that's money, but for this particular problem, we don't know the rest of the money. That's why those are the variables. So what did he get for $220? He got 8 t-shirts and 5 pairs of pants. So t-shirts is X, so he got 8 t-shirts, and pants is Y, so he got 5 pants. And all of that totaled $220. The next day, he purchased 5 t-shirts and 1 pair of pants. And he got $112, paid $112. So $112 is our total. And again, that's money, but we don't have any other money. But what did he get for $112? He got 5 t-shirts, t-shirts is X, and 1 pair of pants. Now, when you type this in the computer, that 1, that's an invisible 1. So technically, you don't have to put it. So it should just be 5X plus Y equals 112. So 5 shirts plus 1 pants equals $112. So we need to solve. Can we make our x's opposite? Go to the smaller number. Can you multiply something by 5 to get 8? No. So then go to the other side. Go to y. Are they opposites? No. So could we multiply something by y to get 5? Yes. We can multiply by 5. However, we need them to be opposites. This one's already positive, so we need this one to be negative. So we want to multiply by a negative 5. So I'm going to take that equation and multiply by negative 5. So the first equation stays the same. And then multiply the second. Negative 5 times 5x is negative 25x. Negative 5 times y is negative 5y. Negative 5 times 112 is negative 560. Now when you type these into the computer, you're going to want to put the original equation before you multiplied anything out. In the equation box, you're going to put 5x plus y equals 112. Do not put these. Put the original equations. Okay, so now we're just going to combine them up. Let's add them up. So 8x plus a negative 25x, that's negative 17x. 5x minus 5y minus 5y is 0. That cancels out. 220 plus a negative 560 is negative 340. Then we divide. Divide out your negative 17. Negative 340 divided by negative 17 is 20. When you're dividing negatives, if you accidentally drop a negative, if you get negative 20 here, think about your problem. X is the cost of t-shirts. Are you going to pay negative $20 for a t-shirt? No, that doesn't make sense. So when you're looking at word problems, make sense of it. That $20 should be positive. So if you make a mistake somewhere and you get a negative number, double check that. Make sure it's positive. And then plug it back in. You can go to either equation I'm going to go with the second one. So 5x, x is 20, plus y equals 112. So just plug it into your equation and solve it out. 5 times 20 is 100. That's positive 100, so I'm going to subtract it. So y equals 12. So I know x is 20 and y is 12. What does it mean? Well, our first question said how much does each t-shirt cost? We labeled t-shirts, the cost of the t-shirts, as x. It's not working. 1 second. There it goes. Okay, we labeled the cost of t-shirts x, so that 20, that's your cost of t-shirts, $20. How much for each pair of pants? We labeled pants y, so the cost of pants is $12. And that's it. Okay, so go try the practice, and good luck. If you have any questions, just message your teacher.